This is number 14 on your Unit 10 review on rational functions. So we are asked to sketch this graph and label all asymptotes and intercepts. So looking at 14, I've gone ahead and rewritten it with a horizontal fraction bar there and then fully factored it. So we need to start with horizontal asymptotes, Bobo, Bot, and HTC. This one is bigger on top, so that means we will have no horizontal asymptote. It is actually 1 degree bigger, 2 here and 1 in the denominator, so 1 bigger on top, so we'll have a slant, and we will work with that in a moment. Vertical asymptotes come from factors in the denominator that do not cancel. This is a factor in the denominator. It does not cancel, so that gives us a vertical asymptote at x equals 0. Remember, we take the factor, set it equal to 0, and solve. X is already solved once you set it equal to 0. So x equals 0 is the vertical asymptote there. Wholes come from factors that cancel between numerator and denominator, so we don't have any factors that cancel between top and bottom, so no wholes. Roots come from factors in the numerator up here that do not cancel, so both of these will give us roots, one at -3 for that factor and +3 for that factor, so x equals -3 and x equals 3 will be roots. Y-intercept occurs when x is 0. When x is set equal to 0, the denominator is 0. Can't do that, so that's undefined. There's no y-intercept. We can also note that we have a vertical asymptote at x equals 0, so right on top of the y-axis, and we can't cross vertical asymptotes, so therefore we can't cross the y-axis, and therefore we have no y-intercept. So none on that. So let's start our sketch here. We need to find the slant. Let's do that. Forgot to do that. So we have x squared minus 9, and we're dividing that by x. Everything in front of the remainder will be the equation of the slant. I need an x here to give me an x squared there, x times, and that's it. That's all we can do. So this cancels, and we have -9 left over as the remainder, so minus 9 over x. So everything in front of the remainder is the equation of our slant. So y equals this, y equals x is the slant. Now we have everything that we need to sketch it. So we have a VA here at x equals 0, so right on top of the y-axis. We have a slant asymptote of y equals x, so that's a slope of 1 through the origin here. And we have roots at +3 right here and at -3 over here. Change that a little bit, put it right there. Based on this information, where the asymptotes are and where the roots are, that tells us that the graph has to approach the slant asymptote here, go through that root, and then approach the vertical asymptote down here. So it's probably not the best looking curve there, but it has to look something like this on the right side. And then over here we have to approach this vertical asymptote at the top here and then come down and through that root at -3 and then approach the slant here. So that is the way number 14 looks based on where the asymptotes are and the roots are. So that's it for this one. We'll move on to 15. Now for number 15, we have 2x squared plus 5x minus 12 all over -x plus 2. So we'll start with, I've gone ahead and I wrote it here with a horizontal fraction bar and then fully factored it here already. So we want to start with horizontal asymptotes. That's Bobo, Bot, and HTC. This one is bigger on top. We have degree 2 on top, degree 1 on bottom. So it's actually 1 bigger on top, which means we will have a slant. So we'll find that in a minute. Vertical asymptotes come from factors in the denominator that do not cancel. That factor does not cancel, and that will give us, if we set this equal to 0 and solve it, it will give us x equals 2. So we have a vertical asymptote at x equals 2. Wholes come from factors in the denominator that cancel with factors in the numerator. We don't have any of those, so none. No factors canceled. Roots come from the remaining factors in the numerator that don't cancel. Both of these are remaining, so they both give us a root. 2x minus 3, set that equal to 0 and solve, you get 3 over 2, so x equals 3 halves or 1.5. And this factor here, set that equal to 0 and solve, you get x equals -4 for another root. Well, the y-intercept occurs when x is 0, so we can evaluate f of 0. It's usually easier to go back to the original function, so cross out everything, every term with an x in it. So we get negative 12 over 2 there. Once we cancel all those out, negative 12 over 2, so that's equals negative 6. So the y-intercept is 0, comma, negative 6. So that is everything except the slant. So let's find the slant. So we have negative x plus 2 and 2x squared plus 5x minus 12 is being divided by that. Alright, let's start the long division here. So what times negative x gives me 2x squared? That's negative 2x. Negative 2x times negative x, positive 2x squared. Negative 2x times 2 minus 4x. So this cancels. This flips to a plus. 5x plus 4x, 9x. Bring down the minus 12. What times negative x gives me 9x? That's minus 9. 9x here. Negative 9 times 2 is minus 18. So those cancel, flip that to a plus. Negative 12 plus 18 is 6. So my remainder is a positive 6 over negative x plus 2. So everything in front of the remainder is this equation of my slant. So negative 2x minus 9, y equals negative 2x minus 9 is the equation of the slant. So we're going to need some more room here to sketch this. So I'm going to rearrange the screen a little and we'll go from there. Alright, so we've got a coordinate plane put in now, and we can start graphing this thing. We have the vertical asymptote at x equals 2 through here, and then we'll put the slant in. Slant has a y-intercept of negative 9 and a slope of negative 2. So I'm going to change the scale a little bit so we can have room. That's negative 9 there. We need the x-intercept for this so that we can be more accurate with our sketch and find out where this slant asymptote will cross the x-axis. So we set y equal to 0 and solve for x. So that would be add 9 here, add 9 here. And we get 9 equals negative 2x, divide by negative 2. And we get x equals negative 9 over 2, which is negative 4.5. So based on the scale that I have, we're putting negative 4.5 right there. And we'll put our slant asymptote through those 2 points. That's definitely not the best sketch ever, but that's okay. Alright, and then we have roots at negative 4, so that's just inside that slant right there. I'm going to change the color on that. Right there. And at 1.5, 3 halves is 1.5, so about right there. And that is all of the information. Oh, we have a y-intercept at negative 6. And that's all that we have. So based on this information, where the asymptotes are and the roots are, I know that the graph looks like this in this section. So how far down it goes, I'm not exactly sure, but that doesn't matter. I know it looks like this. That's the shape. Now I have to determine, is there graph over here or over here? So I need one extra point. So we'll evaluate f of 3 and see what that gives us. So f of 3 is equal to, going by the original function, that would be 2 times 3 squared plus 5 times 3 minus 12 all over negative 3 plus 2. So just plugging in a 3 and putting a 3 into the original function. So let's do that work. So that would be 18 here plus 15 here minus 12, and then negative 3 plus 2 on the bottom. So that would give us 21 on top, and negative 3 plus 2 and negative 1 on the bottom, so that's negative 21. So the ordered pair is 3, negative 21. Based on that information, it has to be down here in this section. So negative 3, 3, negative 21, we'll label that right there. So it has to look like this in this lower section. And we had 4 sections, 1, 2, 3, and 4, and we put the graph where it goes in the sections. There can't be any graph in this section because that would fail the vertical line test with this part, and there can't be any graph in this section because that would fail the vertical line test with this part. So that's it for number 15. All right, last one for the review, number 16. We have in a rational function here, and we have to write the function given the graph. So we'll identify the major components. We have roots at x equals 0 and x equals 2. So root 0 there, 2 there. We have a slant asymptote, and in all of these problems the slope of the slants will be 1, and you can tell that it's crossing at positive 2 on the y-axis there and at negative 2 here, so it's up 1 over 1 for the slope. So that means our m is 1, so we need a 1 in front of the function when we write it. The 1, we'll just write it for effect. It technically doesn't have to be there. And then the last thing that we know for sure is that we have, actually it's not the last thing, but we have a hole in the graph at x equals 1, 2, 3, 4, 5, 6, 7. So that x value is 7, x equals 7, y coordinate doesn't matter in this case. And then we have a vertical asymptote, that's the last thing we know, at 1, 2, 3, x equals 3. So we write the function here based on that information. So we'll put the 1 in the very front, that's the slope, whatever the slope is, or value of the horizontal asymptote, if it had one, goes in the front. We have a slant, so no horizontal. Slant slope is 1, so that's why that 1's there. And then we have, we need an x on top for this root. We need an x minus 2 factor on top for this root. And then we have a hole at x equals 7. So we need a factor of x minus 7 top and bottom for the hole. And then we have a vertical asymptote at x equals 3, so that's a factor of x minus 3. So altogether, 1x times the quantity x minus 2 times the quantity x minus 7 over quantity x minus 7 times the quantity x minus 3. So that's everything. So this gave us a root at 0. This gives us a root at 2. This canceling gives us a hole at 7. And this gives us a vertical asymptote at 3. So that's it.